Hey everybody, welcome to Algo Expert. In this video, we're going to be covering the question of the Caesar cipher encryptor. This is a pretty straightforward question when it comes to string manipulation. In fact, you're not even really going to be manipulating a string here. But what's great about this question is that it really tests your understanding of the modulo operator. And so we're going to be covering two different solutions of this question in this video. The question basically gives you an input string. Here I've got the string XYZ as the example. And for the sake of this video, we're just going to assume that the string is always non-empty and that it only consists of characters or lowercase letters from the English alphabet, right? But depending on how your interviewer might want to ask you this question, you might get strings with a bunch of other characters, right? And that would be something that could make this question a bit more complicated. And then you also are given an integer value. Here we've got 2. This integer value represents a key that will be used to shift letters in the input string. And the question asks you to write a function that's going to take these 2 values and then return a new string which is obtained by shifting every letter in the input string by a certain number of positions in the alphabet, and that certain number is the key that we are given here too. So in this example, if you were to shift this string by 2 in the alphabet, you would get the string ZAB. And so you'll notice that the tricky part comes where when you reach the end of the alphabet, so here, Y and Z, if you shift them by 2, you kind of get out of the alphabet, and the question wants you to wrap around the alphabet, and so you would obtain ZAB. Because if you were to shift Y by 2, right, you would shift it by 1 to Z, and then again by 1 back to A at the beginning of the alphabet. So ZAB. So how do you solve this question? Well, first of all, the pretty straightforward thing to do is to kind of create an array, and this array is going to contain all of our new letters. And so you iterate through the input string, in this case XYZ, and at each letter, right, you call another function or you apply some kind of formula that'll shift that letter by the key, get a new letter, and then throw that new letter in this array, right? And once you're done building this array, you join it together into a string and you return that string. But so what do we do in that function or in that sort of formula to shift one letter into a new letter? That's where the crux of this algorithm comes into play. One way that you can incorporate or rather implement this function is to use Unicode values. So if you're unfamiliar with Unicode values, basically, I think all languages or the majority of languages have built-in functions that will take in a character and return that character's Unicode value. So in Python, for instance, the function that does that is the ORD function, O-R-D. It takes in a letter and it returns its Unicode value. And so it turns out that the Unicode value of Z is 122, and the Unicode value of A is 97. And so if you know that, right, or even if you don't know that, but you're just familiar with Unicodes, and you don't know the exact function that gives you the Unicode value, but you know that it could exist or that it does exist, you could mention this in your interview and implement it without actually knowing if the function exists, but your interviewer would probably appreciate the logic behind it. But so once you have this, right, once you know this, you can implement the function that shifts a letter in a pretty straightforward way. You can start by saying our new letter code, right? Our current letter has a given letter code, a given Unicode, but we're going to define a new letter code, which we'll call NLC. And that's going to be equal to, and here you call the ORD function, or whatever it is in your language, ORD on the letter plus the key, right? And so that gives you your new letter code. And then you might be inclined to say, okay, now just convert that new letter code back to a letter, and you're done. And so in Python, the function that would take in a number, a code, right, and return the corresponding letter is the char function, CHR. The thing is, it's not as simple as that, because if you have, let's say, the letter Z, which we do have in our input string, the NLC for Z would be something like NLC equals 122 plus 2, which is 124, right? And if you call the char function, the function that gets back a character from a Unicode value, if you call it on 124, you're not going to get B. You're going to get some other character. So we want to somehow wrap this 124 back to 98, which would be the Unicode value of B. So how do we do that? Well, we're going to use the modulo operator, which we can shorthand as mod. So you're going to do some kind of if statement, a check, where you say, if NLC, in this case, is less than or equal to 122, well, then you return the char function on NLC, right? Otherwise, you return the char function of 96 plus NLC mod 122. So what are we doing here? Well, we're saying, let's say we get 124, right? When we do z plus 2, so 122 plus 2 equals 124. Well, we mod 124 by 122. We divide 124 by 122 and get the remainder, which is going to be 2. So we say 124 is equivalent to 2. And then we add this to 96, which is kind of the thing that comes right before 97, which corresponds to A. So why are we doing that? Well, because Z, we want Z to turn into B, right? So 96 plus 2 is going to be equal to 98, which corresponds to B. And so that's the formula here that you want to apply. And that's pretty much it, right? That's how the algorithm functions. Now, before we dive into a different way of solving this, we have to talk about a slight edge case, which your interviewer might bring up if you don't catch it yourself. And that's what happens if the key is like a big number. So instead of having a key as 2, let's say our key is like 53. Okay. So if our key is 53, or rather, actually, let's not do 53. Let's do 54. The reason we do 54 is because 54 would give us the same answer here, right? XYZ with the key 54 would turn into ZAB. How do I know that? Well, because 54, right, is equal to 26 plus 26 plus 2. If my arithmetic is correct. 26 plus 26 is 52, plus 2, 54. And we know that 26 just gives us the same string, right? Because we shift the letters by 26, so it brings us all the way back to the same letters. And so if we shift by 54, we shift by 26 once, then by 26 once, and then by 2, and we get ZAB. But the thing is, here in our formula, right, we would have an NLC that would definitely be greater than 122. We'd have an NLC that would probably be equal to, something like 140 plus something, right? I didn't really calculate it here, but it would be bit bigger than 140 or 150. And then when you mod that by 122, and you add the value back to 96, your result is still greater than 122. So you end up still calling the car function on something that's greater than 122, and that's not what you want, right? You want to wrap around the alphabet. So what we can do at the very beginning of our algorithm, instead of dealing with a big number like 54, what we can do is we can say, let the key be equal to our whatever our given key is, and then mod that by 26, which is the number of letters in our alphabet. And so by doing this, we don't end up in these tricky situations where we have a number that even mod 122, when it's added to 96, is greater than 122 and is outside of our alphabet size. So that's a little edge case to think about, or that someone might bring up in an interview. Now, some of you might be saying, wait a second, I didn't know that there were functions in programming languages that get the Unicode value. Or maybe I did know, but I didn't know what they were exactly, and I wouldn't feel comfortable going to an interview and saying that I have an idea but don't know how to implement it. Is there another way to solve this problem? And the answer is yes, right? Because the basic idea behind this Unicode value thing is just to associate a letter with a given code. And you can do that yourself. Instead of using these Unicode values, you can create an array or a list, right, of all the letters in your alphabet. So A, B, C, D, blah, 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 all the way to Z. And the index that each of these letters are at, right, is their corresponding Unicode value. So the letter A would be at index 0, and that would be its corresponding Unicode, or its corresponding code value. And the letter Z would be at index 25. So here you could replace 122 with 25 and replace 97 with 0. And then in our formula here, what you could do is you could say if NLC is less than or equal to 25, return, instead of car, you would return, let's say your array of the alphabet is called AL, you would return AL of NLC, right? And then here, instead of returning this thing, you would return AL of -1. -1 is the equivalent of 96 here, plus NLC mod 25. Oops. And that would be your formula. And the last thing here, to get the actual NLC, to get the code, you would have to add the key not to the ORD function here, but you would say AL, your alphabet array, dot index letter. You would get the index that letter is located at in the alphabet array. And that's how you would do this question without using this Unicode stuff. So now let's analyze the time and space complexities of this algorithm. Pretty straightforward. Time complexity is going to be O of n. Time equals O of n, where n is the length of our input string, in this case XYZ. Why is it O of n? Well, because at each point, we're iterating through every letter in this string, and at each of these letters, we're applying this other formula, and this formula runs in constant time, right? We're just getting the Unicode value of a letter, or doing a few operations, doing some mod operations, but nothing too fancy. Now, it is worth pointing out that if you were doing the approach that uses this alphabet array, you'd be calling this dot index function, right, to find the index at which this letter is located in your alphabet. And with an alphabet of only 26 letters, like we're dealing with in this example, that just becomes a constant time operation, right? O of 26, which goes down to O of 1. But if you were dealing with a greater alphabet, maybe an alphabet of length m, well, then this would actually be an O of m time operation. So that is something that's important to notice, and it's important to bring up in your interview. If you were just dealing with lowercase letters, but you brought up what I just brought up, that would probably give you a lot of bonus points, because it would really show that you are kind of aware of all the sort of operations that are going on in your functions, and what their time complexities could be depending on the size of inputs. Now, space complexity is going to be the same thing, O of n. Why is it O of n? Well, because you're creating an array and then a string of length n, right? So naturally it has to be O of n. And then you're not storing anything else anywhere. Once again, it's important to point out, if you're doing this alphabet method, if you only have 26 letters, your alphabet array is only going to be of length 26. But if you have an alphabet of length m, then this array is going to be an array of length m. And so you will need to store an array of the alphabet of length m, and so that would increase your space complexity. So it's important to mention this in your interview, or at least be aware of it. Anyway, that is it for this algorithm. I hope this was helpful. We're going to dive into the code walkthrough now, which should be pretty fast and straightforward. All right, so we've got our Caesar cipher encryptor function defined. It takes in a string and a key. And the first thing we're going to do is we're going to define our new letters array. And then we're also going to define our new number, or our new key. And that's just going to be the key mod 26, as we mentioned in the conceptual overview. And then we're going to iterate through our string, 4-letter in string. And at each of these, at each letter, right, we're going to apply our formula that's going to shift that letter. And we're going to push the new letter to our new letters array. So we're going to say new letters dot append get new letter, which is going to be a function, right, that we define. Letter, we're going to pass it in letter, and new key. And finally, we can just return and join our array into a string, right? So that's as simple as that for the first function in this algorithm. And then we define our helper function, our get new letter helper function. It's going to take in letter and key, as we said. And first we calculate the new letter code. So the new letter code is going to be equal to ord of letter. Here we're going to apply this, the Unicode thing at the beginning. So ord of the letter plus num. Once again, just so that you don't forget, ord is the Python function that gets you the Unicode value of a character. Do look up the corresponding function in your language. I think if you're in JavaScript, it's car code from, something like that, or car code at, dot car code at, something like that. Anyway, finally, once you've got this new letter code, you can return and you call car on it of new letter code if new letter code is less than or equal to 122. Else, so you're doing a ternary operator here, else car of 96 plus new letter code mod 122. So what are we doing here? We're saying if the new letter code is less than 122, then return the corresponding letter. Otherwise, return the letter corresponding to 96 plus new letter code mod 122. And that's the algorithm. It's as simple as that. This runs in O of n time and O of n space. Now, if we want to do the other implementation, let's comment this out. The other implementation is also going to run in O of n time and O of n space. And the other implementation is going to be almost as simple. The only thing is here we're going to add an alphabet, right? We're going to add an alphabet array. And in our case, this is going to be an array of all the letters. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. I hope I didn't miss any letters here. So we create an array of our alphabet. And then we pass in the alphabet to our get new letter function. And so here we don't forget to add an alphabet in this get new letter function. And I just noticed here that I used the variable num. I think I meant to use key. So let's replace this num with key here. Yeah, that definitely was supposed to be key. And so we're going to say here new letter code is going to be equal to not ord of letter, but instead alphabet dot index of letter. We get the index that the letter is located at in our alphabet array, and we add the key. And then we can return here, instead of this, we can return alphabet of new letter code if new letter code is less than or equal to 25 here, right? Because that's the index of Z. Else, alphabet of -1 plus new letter code mod 25. So we literally replaced 122 with 25 and 96 with -1. And we're done now. This algorithm once again runs in O of n time O of n space. If you've got an alphabet that's greater than 26 letters, maybe a length m, then you need to mention that, and you need to kind of show that, reflect that in the time and space complexity analyses. But for this particular example, it is as straightforward as this. So I hope this video was informative. Hope it was helpful. I'll see you in the next one.